All right, in this lesson, we'll extract values from a series by the index label. We're actually not going to need our Google series here, so I'm going to cut this code out, at least for this lesson. And I'm also going to cut out these parameters at the end here. We might enter a few of them back, but I just want to explain what we're doing here step by step. And in order to see the result, I'm also going to actually assign the resulting series to the Pokemon variable a little bit later. But let's take a look at what happens when we import our CSV with just the CSV name. You can see that Pandas defaults to a data frame, which is its two-dimensional object that we'll dive into very soon in the upcoming module. And in this case, we have two columns, Pokemon and type, and in all previous lessons, we've just been using the Pokemon column. In this lesson, I want to use the Pokemon column actually as the series index and leave the type as the values within the series. So I'm going to introduce a brand new parameter that's available on the readCSV method, and that's called index_call, and that just means index column. And this is where we can provide a string that will serve as the series index. So what we want to give here is the name of one of the columns from our CSV. So if we want the Pokemon column on the left to serve as our index in our brand new series, we can just write Pokemon. And I'm matching the case that's right here. This is the column that I'm referring to as a string, Pokemon. Let's execute this to see what happens. We can see that we're sort of getting to the right place because the Pokemon column has now become the index, but you can see by the fancy graphic feel here that this is actually still a data frame. The series, as I mentioned, is a little bit less fancy in the way it looks. And the reason for that is because we actually need to include that squeeze parameter still and set it equal to true to ensure that that one remaining column within that CSV is imported as the series values instead of as a data frame. So once we execute this, now we're actually going to have a series where the values are the types of Pokemon and the index represents the Pokemon names. So now that I'm satisfied, I'm going to reassign this back to Pokemon, and I'm also going to preview the first three rows just so that we have a, kind of an awareness of what we're dealing with here. So in the last lesson, we talked about extracting values by index position. And what's cool about Pandas is that even when you have string index like here, where Bulbasaur and Ivysaur form our index labels, behind the scenes, every item in the series, every value, still gets its own index position. So for example, Bulbasaur is our very first index label, and that's in the 0 position. So if we use the syntax from the previous lesson and just enter 0, even though there's no explicit 0, so to speak, in our index, the index is made up of strings, it's going to return grass, which represents this value right here for Bulbasaur. So we can continue using that index position syntax even if our index is made up of strings. That's one of the ways that Pandas series, as I mentioned, combines the best aspects of both a dictionary and a Python list. And similarly, if we wanted more than one index position, we can do 100 and 134, for example, and it's going to give us a brand new series where we can see now that Electrode is the name of the Pokemon in the index position of 100, and Jolteon is the name of the Pokemon in index position of 134, and we get the corresponding values at those two positions just the same. But what's great here is that this syntax also works for regular index labels. So for example, if I put my square brackets here and I do something like Bulbasaur, which is our very first Pokemon, we're going to get the corresponding value for that index label, and it's going to be grass. Similarly, if I execute something like Ditto, so I'm going to write that in double quotes within my square brackets, there it's going to return the corresponding value from the series, which is normal. We can also apply the exact same operation to do something like a multiple extract. So if I want to pull both Charizard and Jolteon, we can enter that within a list. So we're going to need another pair of square brackets within those first pair of square brackets, which indicates to extract. We now give it two index labels, and it extracts both of them as a brand new series. And it's not limited to two, by the way. If we wanted to do something like a list of three values, Blastoise, Venusaur, and Meowth, we can do that. It's going to give us those three index positions. Here's where it gets a little bit interesting. Whenever we do a value that does not exist, for example, the index label Digimon does not exist, we're going to get an error because it does not exist in the data set. But whenever we do a list of more than one, for example, let's do Pikachu, which we know exists, and Digimon, which does not exist, and remember to put that closing pair of square brackets. Even though Digimon does not exist, it's going to give me a return series. It still returns even though one of the index labels does not exist. So you have to watch out for that, because in this case, Digimon does not actually exist within our data set. It's basically returning a series where it does, though. And you can see for the first time this NaN designation, which we'll run into a bunch down the road. And NaN is short for not a number, and all it is an internal pandas designation that means missing or null or blank. It means that the value does not exist. So the way that pandas represents the Digimon label as not existing is by putting NaN. It's not because Digimon actually exists within our Pokemon dataset and NaN is the value at that position. Digimon is completely absent, but because it's part of this list, it's going to be returned in this new series. So just be careful and watch out for that. And similarly, we can also use the familiar syntax of using our colons in the middle. So for example, if I want to do Pokemon and then create a square brackets, and let's extract everything from Bulbasaur to Pikachu, it's going to be Bulbasaur. I'm just going to put the colon there and do it to Pikachu. That's going to extract all of the index labels starting from where it runs into Bulbasaur all the way to Pikachu. The difference here, and this is interesting, is this time the second value, which is the end, the Pikachu, is actually going to be inclusive. So it is going to be included in our final result set. That's in comparison to when we do index positions where the last position is actually excluded. That's why we always have to add one more to what we actually want to extract. In this case, when you use index labels such as strings, and we use the colon syntax to extract sequential values, this time the end value is included. So that's just a little bit more on how we can extract values by index labels. So now we've seen two ways, by index position and by index label. And in the next lesson, we'll introduce an actual method that we can use to extract values from a series as well.